Here is an example of a failure analysis we conducted several years ago. The failure involved mixing blades that were bending and fracturing during use. The mixing blades were made of stainless steel. It consisted of a stainless steel shaft that was welded to stainless steel plate. And the blades were attached to a shaft inside of some mixing equipment. And so as the shaft spun around, the blades moved through the mixing equipment and stirred the stuff inside of the equipment. And this is similar to the setup shown here, though the blades have a different shape. This shows the equipment shaft and then the blades attached to the shaft. So what was happening is that the mixing blades were bending and fracturing during use. This shows a bent blade, and this shows a fractured blade where the fracture occurred at the weld joint between the shaft and the steel plate. This shows the fractured blade, and then this is a visual image of the fractured end. You'll notice that the fracture is relatively flat and that there's no plastic deformation of the metal. And these are indications of the failure mode for this fracture. This area was then cut out and examined with a scanning electron microscope. And the scanning electron microscope images are shown here. This is a lower magnification image and a higher magnification image. And these fracture features indicate that the material was subjected to high cycle fatigue and that the material indeed fractured due to high cycle fatigue. So this information helped point in the direction of where the root cause may lie. We had to determine where were the fatigue stresses coming from. Well, the only possible source was acceleration and deceleration of the motor shaft in the equipment. And it turns out that the variations of the motor electrical supply voltage caused the shaft to accelerate and decelerate. And the acceleration and deceleration put bending loads on the blades, and the bending loads would reverse back and forth. And as a result, the blades were subjected to fatigue stresses. And also the stress concentration at the weld was also a problem because this just increased the stress in this area. So the solution to the problem was to clean up the electrical power to the motor to reduce the voltage variations so that the blades were not subjected to acceleration and deceleration and the bending loads associated with that. And also, it was decided to cast the blades out of one piece to eliminate the weld stress concentration. So this is an example where conducting a failure analysis and the information from the failure analysis helped point to the root cause of the problem. The root cause was then identified and was eliminated, and subsequently there were no fractures or bending of the blades.